Welcome to this last tutorial on longitudes and latitudes theory. The preceding tutorials, if any, on longitudes and latitudes shall be for follow-ups. But basically, we are going to do a summary, a recap of all that we have done in longitudes and latitudes so that you may have a good foundational basis. So, let's begin with a quick word of prayer and then we shall start off. Father, Lord in heaven, you being the great mathematician, teach us today. Jesus may pray. Amen. Under longitudes and latitudes, because you have covered the topic, you should be able to, one, define great and small circles in relation to a sphere, including the Earth. Great and small circles, you can be able to get the definitions in the previous tutorials, of which we said great circles, they are all longitudes and the equator, and small circles, they are the latitudes that are to the north or to the south of the equator. Basically, the definitions, you can be able to get them there. But because it's a summary, great and small circles, a great circle is a circle in which its radius is equivalent to the radius of the Earth, and a small circle is which the radius is smaller than the radius of the Earth. You should also be able to establish the relationship between radii of small and great circles, of which we said that the radius of a small circle is equal to the radius of a great circle multiplied by cosine of theta, whereby theta is simply the latitude difference. I believe you can also get that from what we covered in our previous tutorial. You should be able to locate a place on the Earth's surface in terms of latitude and longitude. We have also done that in our previous example and in the marking scheme of our assignment. You should also be able to calculate the distance between 2 points along the great circle and small circle, that's the longitude and latitudes in nautical miles and kilometers. In our previous tutorial, you are able also to calculate time in relation to longitudes and latitudes. The longitude rather, latitudes are not used in time calculation. And then finally, calculation of speed in knots per hour, in knots and kilometers per hour, sorry for that. So we are going to do a summary of what we have learned. So this being our globe, or the surface of the Earth, we have various points depending with how man has been able to distribute himself on the surface of the Earth, trying to live everywhere. So from that, you can be able to determine the position of a place by simply having you state that particular point in this manner. You start with the latitude followed by the longitude. That is the way it is stated. So for example, if it's point A, it will be 60 degrees to the north and 100 degrees to the west. If it's point D, it will be 45 degrees to the south and 40 degrees to the east. Quickly, note that there's something that you need to know. This is a very important statement. The distance between 2 points on the same hemisphere is shortest along the great circle. Underline this. Never forget this. This is a very important relationship. For example, if I have point A and point B, they are in the same hemisphere, or point C and point D, they are in the same hemisphere. What this statement means, the length along point A to D along this small circle, it is longer or greater than the one along the small circle. This. So along the small circle, the distance will be greatest than this, the great circle. So the distance between 2 points is on the same hemisphere is shortest along the great circle. So the distance from A to the North Pole, then from the North Pole to B is shorter than from A to B along the small circle. Now to explain that statement very well, though this is not a very good example using my orange, but it tries to explain something. Assuming that this is my Earth, okay? what we simply mean, the distance along the small circle will be greatest. Now you'll notice that this is quite flat here. It's not a very good diagrammatical representation. But if I go to the North Pole and then come back, the distance along the great circle will be shortest. The same thing is also explained from this angle to be like that. This is not a very good example, but I'm just showing a grammatical explanation of what is happening. So that is the same that you need to keep it at heart. The distance between 2 points on the same hemisphere, they must be of the same hemisphere, is shortest along the great circle. So along point number 2, along any great circle, distance, how to calculate distance, this is the basic formula. In kilometers, this will be theta over the 362 pi r, whereby theta is the latitude difference of points along the great circle. In nautical miles, it will be 60 theta, whereby theta is still the same definition in nautical miles. Along any small circle, and in most questions, you'll notice that they'll tell you a small circle or parallel of latitude. So if you're told get the distance along parallel of latitude, no, it's a latitude because it is parallel of latitude. Parallel of latitude. Parallel of latitude. So it's parallel to the latitude plane. That's what they simply mean. The distance is this in kilometers. L alpha over 362 pi r, small r. So it means this small r, it is not similar to this capital R. Notice the two. So what is r? R, whereby r is r cos theta, whereby r is the radius of the earth, theta is the latitude difference, alpha is longitude difference of to get the radius of the small circle. So basically the final formula will be alpha over 362 pi r cosine of theta in kilometers, whereby alpha is the latitude difference and theta is alpha is the longitude difference and alpha is the latitude difference or latitude angle. Basically in this case, you just pick directly that angle. For example, if I was calculating along AB, theta will be 60 degrees. If it was along CD, theta here will be 45 degrees. Speed is read in kilometers per hour or knots, whereby kilometers per hour, this is quite common. Knots is in nautical miles per hour. And then finally, in time calculation, change in longitude between points by 1 degree causes a variation of 4 minutes. The points on east relative position of the longitude have time ahead. The time is usually ahead. So if I have a town D here, it will have its time will be ahead of C. Its time will be ahead of A. So that's what we simply mean from this statement. And a longitude difference of 1 degree will always cause a time variation of 4 minutes. Basically, I still emphasize on calculation of time because we made an assumption, but I would still want to make it quite clear if it's quite problematic. Start with the diagrammatical sketch. These are tips of how to answer that question of time. Have your Greenwich meridian or prime meridian, and then state the two places you want to get their times from. For example, I can have this one as A degrees to the east and this one B degrees to the west. After having the diagrammatical sketch, you'll have a clear mind of how these things are positioned. Next, get the difference in longitude angle. Come here and say it is B degrees plus A degrees. But notice I say difference. This is quite strange. Now, why do I say difference? It is because I'll simply be subtracting this. Let me begin from the common one that will be able to give you a good explanation. If you have two towns, in the same hemisphere. These ones are different, that's why we sum them up. If it's the same hemisphere, it will now be the larger degree minus the smaller one. I believe this one, I remember even we explained this in one of the tutorials. So after getting that particular angle, then come to the relationship of saying 1 degree is equivalent to 4 minutes. What about either whatever you have here? Then afterwards break it down into time, then follow up with the relationship of how to calculate time. So that is what we simply have. So if you have various questions, you can be able to pause them and we can be able to work them out. So with that, we close down the topic longitudes and latitudes, and may God bless you.